In this lesson, we'll be using a buzzer to learn about the while loop, which is commonly used for repeating processes, as well as arrays, which help organize programs efficiently. Let's first understand what a buzzer is. A buzzer consists of a coil and a metal plate inside. When a positive and negative voltage is applied to the coil, it vibrates the metal plate, causing it to oscillate back and forth, creating sound waves in the air. For example, the note A has a frequency of 880 Hz, so by inputting a pulse signal at 880 Hz, the buzzer produces that note. There are two types of buzzers: active buzzers and passive buzzers. An active buzzer has a built-in control circuit that produces a specific sound when a DC voltage is applied. A passive buzzer, on the other hand, lacks an internal circuit and produces sound based on external pulse signals. Since we want to change the sound freely, we'll be using a passive buzzer in this lesson. Here's the circuit we'll be building. The buzzer will play a do-re-mi scale while the button is pressed, and nothing happens when the button is not pressed. The materials we'll use are an Arduino Uno, a breadboard, a passive buzzer, a push-button switch, a 10K ohm resistor, and 5 male-to-male jumper wires. Here's the circuit diagram. A pull-up resistor is connected in series with the switch, so when the switch is off, pin 5 remains at a high level, and when the switch is on, it changes to a low level. The buzzer is directly connected to a digital pin. Next, here is the breadboard diagram. While the internal structure of a passive buzzer is just a coil, it's generally safer to connect the signal to the side with the ++ marking if present. Let's set up the circuit based on the diagram. Now, the circuit is complete. Let's move on to coding. First, install the necessary library. This time, we'll be using a library called pitches, which defines the frequency for each note in the scale. Since pitches isn't a standard library, download the zip file from this GitHub page, then go to Sketch, include library, add .zip library, select the downloaded file, and import it. Next, create a new file and enter the program shown here. We're creating an array called melody to store 8 constants corresponding to the scale do, re, mi, fa, sol, la, ti, do. An array is like a storage box that holds multiple data values together. You could write this code without using an array, but arrays help keep the code cleaner and more efficient by reducing redundancy. In the loop function, we're writing repeated actions using a while loop. A while loop repeatedly executes the code inside its curly braces as long as the condition inside its parentheses holds true. The computer checks the condition, and if it's true, it executes the code inside the braces. It then rechecks the condition and repeats the process until the condition is no longer true. In our case, the state of the switch is first checked, and if it's on, the while loop executes. Inside the loop, the tone function plays each note in the do-re-mi scale one by one. The array melody holds the frequencies for each note, and we read them by specifying the position index. Keep in mind that arrays in programming generally start at 0 rather than 1. There are two important points to remember here. One, you need to include a digital read function inside the while loop to check if the switch is still being pressed. 2, when using the tone function multiple times in succession, you should include a delay between notes. This is because the buzzer creates sound by vibrating, and abrupt changes in frequency can cause strange noises. Once you've saved the file, press the Upload to Board button in the toolbar to write the program. If everything is correct, you should hear the buzzer playing the do-re-mi scale in order while the button is pressed. That concludes this lesson. Try modifying the program to play sound only when the button is released, and then move on to the next lesson. That's all for now.